Hi everyone, today I want to show you how to solve some systems of linear equations word problems. I call these greatest hits. You'll find as you do systems of equations word problems that they tend to fall into some categories. I mean, at first it seems like every problem is different, but with practice you'll start to notice, oh, this is kind of the same as that other problem, and you'll start to get familiar with these word problems and it'll come around. So let me show you some of the categories. So here we go. Number one, mixture problems. Here's an example, two types of milk, one that has 1% fat and another that has 3.5% fat are mixed. So I'm going to solve this kind of problem using a table. So let me show you how I do that. I think it's a good system. So I'm going to draw a table with 4 columns. And this is the 1% milk. This is the 3.5% milk. So I have in my 3 columns an amount, sorry for my messy writing, a percent, and a total. So the amount of 1% milk I could use X, but I'd like to use a variable that will remind me that this represents the 1% milk. And I could use O for 1, but that looks like a 0, so that will confuse me. So I'm going to use W for 1, even though, of course, I'm spelling badly. And the 3.5% milk, I'm going to use T for 3.5%. Now what percent is the 1%? What percent of that is fat? 1%. So I'm going to write that as a decimal, 0.01. And the 3.5% is 0.035. So generally for a lot of these systems problems, you fill in these 4 boxes. And then the rest of the boxes come from that information. So the total amount of milk I'm going to have is W plus T, which I already know from the problem is 10 liters of milk. The total amount of fat in the 1% milk is 0.01 times W. So this far right-hand column is usually filled in by multiplying across. This will be 0.035 T. This column I can either use blank, but I remember that it's going to end up being 2% milk. So the total is 10 times 0.02, which is, what is that? Is that 2.2. So now I have a system of equations. I can say that W plus T equals 10 and 0.01 W plus 0.035 T equals 0.2. And I'm not going to teach you how to solve this system of equations in this video. We have already learned how to do that, or we can watch videos, but I would use substitution for this one. All right, let's look at another example. The admission fee at a small fair is $1.50 for children and $4 for adults. On a certain day, 2,200 people enter the fair and $5,050 is collected. How many children and how many adults attended? So at first, this might seem very different from that milk problem, but actually it's quite the same. So I'm going to make a table with 4 columns, and instead of 1% milk and 3.5% milk, I have children and I have adults. And instead of the amount, that's the amount, and I know that that adds up to 2,200 people. And instead of 1% for the amount of fat in milk, I'm going to write $1.50 for the amount that a child pays. And I'm going to write $4 for the amount that an adult pays. So we can call that the percent or the cost, maybe cost, but I'm getting, that's confusing because I already used C for children. All right, so the total, I don't know why I have so many columns here, is 1.50C and 4.00A. So again, I filled in these 4 boxes and I multiplied across to fill in these 2 boxes. Sorry, that's so messy. Then I add down to get a total. C plus A is 2,200, and I add down to get a total amount of money, which is $5,050. So I have 2 equations. C plus A equals 2,200, and 1.50 times C plus 4.00 times A equals 5050. Okay, let's look at another example. I'll leave it to you to solve that system of equations. Let's look at another example. Bob has a mixture of nickels and dimes, and he has 28 coins worth $2. How many of each type of coin does he have? So I have nickels and I have dimes, and that adds up to 28 coins. The cost of a nickel is 5 cents, which I'm going to write as 0.05. And the cost of a dime is 10 cents, which I'm going to write as 0.10. So I complete these 4 boxes, I multiply across, and this column represents the amount of money. The amount of money I have in nickels is 5 cents times the number of nickels, and the amount of money I have in dimes is 10 cents times the number of dimes, and that adds up to the total amount of money I have, which is $2. So my system of equations is N plus D equals 28, and 0.05 N plus 0.10 D equals $2. So there's my system of equations, which I will leave for you to solve. All right, rate and distance problems. Leah walks to the mall from her house, and again, this is just a mixture. It's a mixture of Leah's activities and Megan's activities. So in this case, I'm going to use a formula: rate times time equals distance. Hopefully you recognize, oops, eraser please. Rate times time equals distance. So I have 2 people here. I have Leah and I have Megan. And Leah's rate is 5 miles per hour. And Megan's rate is 15 miles per hour. Now, you might think, well, that could just average that, but that's not true, because the amount of time, there's more Leah time than there is Megan time. Okay, so we know that the amount of time that we don't know the amount of time that Leah takes to get to the mall. So I'm going to use a variable. I'm going to use L for Leah. And we don't know the amount that Megan uses to get to the mall, but I know that she leaves 10 minutes after Leah. And you have to be careful, because you might think, well, to get from Leah's time to Megan's time, I have to add 10 minutes. But actually, if you think about it, Megan is on the road for 10 minutes less because she left later. So Megan's time is L minus 10. This is just a little bit different strategy than I used for the other examples. But I am going to multiply across to get the distance. So this is 5L. And this is 15 times L minus 10. Oh, I just recognized that we're going to have a problem. I had just realized that I'm using 10 minutes. You see that? That's 10 minutes. But the rate is in miles per hour. And so that is, if I'm inconsistent like that, I'm going to run into problems. So I'm going to change this 10 to 1 over 6, because 10 minutes is 1/6 of an hour. So I want everything to be in hours. Change this to 1 over 6. Make sure your units are consistent. All right, so for distance problems, I fill out the 4 boxes, just like I did here, and I multiply across. And the question I have is, what is the relationship between these two distances? So I have this distance, and I have this distance. What is their relationship? So for distance problems, there's going to be kind of 3 relationships. One is where the 2 people are far apart from each other and they meet somewhere in the middle. And then the question will be, they will probably tell you the total distance. And you would say that this one plus this one adds to some total distance. Okay, that's not the case here. They don't meet in the middle. If Megan had left the mall and Leah had left her home and they met in the middle, we would say their 2 distances added to some total. Another one is where the 2 girls go in opposite directions. So they start at the same place and they go apart, and then their 2 distance will add up to some total distance apart. You'll add the 2. Okay, but in this case, what's happening is they both start from home. They both start from home, and they both end up at the mall. So what is the relationship between their 2 distances? They're equal. So 5L equals 15 times L minus 1 over 6. And I'll leave that to system. That's not a system, that's just an equation in one variable. I'll leave that for you to solve. Okay, example for today. 2 angles are supplementary if the smaller angle is 3/5 the size of the larger angle. What is the size of the smaller angle? So what I know is that the smaller angle, which I will say is S, equals 3/5 of the larger angle. And I also know that the 2 angles are supplementary, so smaller angle plus larger angle equals, supplementary means they add to 180. So for this problem, I'm going to use substitution. I know that S equals 3/5 of L, so I'm going to replace and say 3/5 L plus L equals 180. I'll leave that for you to solve, but I'll leave it with a warning. When I'm done, I'm going to get a number for L. And this is why it's important not to use something like X and Y. Using L reminds me that that variable represents the larger angle. And the question is, what is the size of the smaller angle? So I won't be done when I get L. I need to multiply L by 3/5 to get S. All right, well, there's some examples of systems of equations. I'll give you some problems to practice, and good luck.